We're going to learn how to write formulas for ionic compounds first, section 5.5. So let's very quickly review the elements that form ions with predictable charges. The nonmetals form ions with predictable charges. We talked about pretending it was a board game and counting backwards. So the noble gases are 0. They don't form any ions. We go 1 to the left, fluorine, chlorine, bromine, iodine are -1. We go 1 column over from that. We get -2 for oxygen and sulfur and selenium. We go over 1 more. We get nitrogen and phosphorus have -3. Non-metals form negative ions. Metals form cations, positive ions. The ones in group 1 form +1 ions. The ones in group 2 form +2 ions. The ones in group 3 form +3 ions. The other guys we'll learn about. So when we're writing formulas for compounds, we have to remember that the compound itself is neutral. It doesn't have a positive or negative charge. So the number of positive charges has to equal the number of negative charges. And we can predict the formula by looking at the charges and figuring out how they balance out. It's not that we're putting things in there, although we think of it that way, but that's how we figure out how to describe what nature does. So to write formulas, what happens is we'll be given the name and we'll be asked to write the formula. So you write the symbol for both of the ions, including the charges. The charges are really important, okay, because the charges are going to tell us how many of each to put together. So we're going to make the magnitude of the charge on each ion without the sign become the subscript for the other ion. This is one technique. It's the one that most students like, and we call it Criss Cross. Okay, so what I've got here is what's straight out of your book. I would prefer to amend it a little bit. Maybe I'll just actually write that on here. Okay, let's call this 1B. Well, I don't know, whatever. If the charges are the same, you just need one of each. If the charges are the same, one of each ion. So like sodium chloride, you've got sodium is +1, chlorine's -1. You don't need to do any crisscrossing. You just push them together. Their charges add up to 0. If you've got calcium and oxygen, calcium's +2, oxygen's -2. You don't need to do any crisscross and reducing or anything. Just push them together. +2 -2 adds up to 0. Doesn't matter what they are, if they're equal, positive and minus, negative, that's what you do. Okay, and then what we're going to do, if they're not equal, then we'll do that crisscross thing, and then we can ignore that for the most part. The subscripts need to be in the lowest ratio. With the crisscross thing, there's just a couple of situations where you could end up with something like a ratio of 2 to 4, but most of the time you won't. And then always make sure to check that the sum of charges of the cations, the positive charges, exactly equals the negative charges. So let's do some examples. Here's looking at the ionic compound formed between aluminum and oxygen. The first step is to write the formulas for the ions with their charges. So we would find aluminum on the periodic table. We see it's in group 3A. It has a +3 charge. So there we go, Al3+. Oxygen is 2 squares over from the far right. It has a -2 charge. And then we're looking at those. We've got +3 and -2. Those are not the same. So then we could do that crisscross thing. And so we're taking this 3, and that's going to become the subscript for the other ion. And the 2 is becoming the subscript for the other ion, the first ion. So we get Al2O3. That's the one that students like the best, probably because it involves the least thinking. But there are other ways to think about this, and so I'm going to show those to you. So here I've got aluminum 3+ and oxygen 2-. So one way to think about this, the more math way, is to think, well, what's the least common multiple of those two numbers? The smallest number that they are both factors of is going to be 6. So I need to get 6 positives and 6 negatives. So I'm going to take the aluminum and multiply by 2, and I'm going to take the oxygen and multiply by 3. 2 times 3 is a total of negative 6. 3 times 2 is plus 6. And that's how I get the right number of charges. So I've got 2 aluminums, and I've got 3 oxygens. Same result, different thought process. Okay? So that will make sense to some people. If it makes sense to you, great. If it doesn't, do the crisscross thing. Okay, here's another way. Oh, I don't know why I'm doing iron. It's aluminum. So this is the more visual way. So I've got these two guys. And down here, I'm going to keep track of my total positives and negatives. So just with one of each, I've got plus 3, and I have minus 2. That's not going to work. I need more positives, right? Well, I can't put in one more. I have to take a whole nother oxygen ion. So that's going to be a 2 minus charge. So now I've got minus 4 over here. Well, now I've got imbalance in the other direction, right? Now I need more positive charges. So I'll put another one of these guys in here. You can probably see where I'm going. So now I've got plus 6. Oh, good grief. Are we ever going to end up even? Yeah, we will. So now we've got too many positives, so we better add another negative. And so that gives us minus 6. Phew, balanced out. Now count them. I've got 2 of those, and I've got 3 of these. So my formula is Al2O3. Okay, so there you have 3 different ways to think about putting ions together. The charges are telling us how many of each ion is needed. Any questions? Is there ever going to be more than 2 ions?
Also that when the Criss Cross method.
We will never have more than 2 ions. There's always one cation and one anion in this class. There are things that have multiple ions, but we don't talk about them in Chem 3A. Yeah. This is a nice thing about, beginning chemistry is there are some things that we can just gloss over or ignore. So let's look at this one. Mg2 plus, O2 minus. So with the book instructions are saying to crisscross the charges and then reduce from 2 to 2 to 1 to 1. Makes more sense to me to look at magnesium 2 plus and O2 minus and say, oh, I've got plus 2 minus 2. I'll just shove those guys together and we're good. Isn't that easier? So if the charges are the same, then it's just MgO. Whoops. So Mg and O. End of story. So let's do an example where they're not showing us the answer. Write the formula for the compound that forms from calcium and bromine. Well, we need to know what the symbol for calcium is. It's Ca. What charge does a calcium ion take? What group in the periodic table is it in? It's in group 2A, so it forms a 2 plus ion. And then we have bromine. Bromine forms what kind of an ion? -1. Okay, now we have our formulas with their charges. We look at the charges. +2, -1, not the same. So we can do that crisscross thing. You can take this 2, and that comes down here, and that 1 that we didn't write becomes a 1 that we don't write over there. So we got CaBr2. We've got +2 charge. Each of our anions is -1. We're going to need 2 of them to balance that charge. Okay, the crisscross thing is just like a cheat. Okay, you don't actually have to understand what you're doing, but you can mostly get the right answer. I think it's good to understand. But getting the right answer if you don't understand is better than getting the wrong answer and not understanding, right? Do you follow that? What's it doing? I don't know what it's doing.